So question number 8 is a probability question, and we're using a continuous random variable. And I know that from 0 to 4, the area under the curve will have to equal 1. So I'm going to use that to show that k equals 1 on 64. Okay, so I know that 1 will equal the integral of k t times 16 minus t squared dt, going from 0 to 4. Which means that 1 equals, I'll put a k out the front there, from 0 to 4 of 16t minus t cubed dt, which is going to equal 1 equals k, t squared on 2, so 8t squared minus plus t to the 4 on 4 from 0 to 4, which means 1 equals k, 8 times 4 squared is 16, plus 4, so it's 16 times 16, all divided by 4. Sorry, minus 0, minus 0. 1 equals k, 8 times 16, so 16 times 8, 8 sixes are 48, carry 4. So 128 plus, so that 4 times, that's a minus, that's a minus, which means 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 that's a plus. So I've got 64, 1 equals 64k, k equals 1 on 64, shown. Part 2, find the expected time. Well, e of t will be the integral from 0 to 4 of t times f of t dt. So it's going to equal the integral from 0 to 4 of 64, 1 on 64 t squared times 16 minus t squared dt, which will equal 1 on 64, integral from 0 to 4 of 16t squared minus t to the power of 4 dt, which is 1 on 64 times 16 on 3 t cubed minus t5 on 5 from 0 to 4. 1 on 64 times 16 times 4 cubed is 64 on 3 minus t cubed, so that's t to the power of 5 is 4 cubed times, so that's going to be 16 times 64 on 5. And the reason I wrote 4 to the power of 5 as 4 to the power of 3 times 4 to the power of 2, 64 times 16 is this 64 will cancel with those 64s to leave 16 on 3 minus 16 on 5, which is all on 15. 5 16s. 30 carry 3, that's 80, minus 3 16s is 48, which is 32 on 15 should be my final. And in part C, we have a probability question. Probability person is to queue for more than 2 minutes, given that they have queued for 1 minute, should the probability that time is bigger than 2, given time is bigger than 1, should be the probability of time bigger than 2 over the probability of time bigger than 1, which should equal the integral from 2 to 4 of 1 on 64 t 16 minus t squared dt over the integral from 1 to 4 of 1 on 64 t 16 minus t squared dt. Golly, a lot of arithmetic in this particular question. So my 1 on 64s will cancel themselves. because they can be brought out the front and then just cancel themselves. So I'm going to have the integral from 2 to 4 of 16t minus t cubed dt over the integral from 1 to 4 of 16t minus t cubed dt, which is 8t squared minus t to the 4 on 4, going from 2 to 4 over 8t squared minus t to the 4 on 4, going from 1 to 4. So I've got 8, 1 squared minus 1 to the 4 on 4. Minus 4 over 128 minus 64 minus 8 minus 1 quarter, which should give me 64 minus 28 on top of 64 minus... Okay, so this is actually 31, which means I've got 31 on 4. So that's the same as 9 goes into that 16 on 25. So 16 on 25 is going to be my probability.